Hello, good day. For today's lesson is about graphing rational function. Before going forward, let us recall the following terms. First, we have the domain. The domain of a function is the set of all values that the variable x can take. The range of the function is the set of all values that the function will take. The zeros of the function are values of x which can make the function 0. The x-intercept is the function value when y equals to 0. Then y-intercept is the function value when x is equals to 0. The vertical asymptote are the restriction on the x values of a reduced rational function. To find the restriction, equate the denominator to 0 and solve for x. Then for horizontal asymptote, let n be the degree of a numerator and m be the degree of the denominator. Take note that if n is less than m, your y is equals to 0. If n is equals to m, then your y is equals to a over b, where a is the leading coefficient of the numerator and b is for the denominator. If n is greater than m, then there is no horizontal asymptote. Let us solve for the first problem or example. So we have the first example. Consider the function f of x equals to x minus 2 over x plus 2. Then find its domain and intercept. Then sketch its graph and determine its range. Okay, first the domain. So to find for the domain, you have to look at the denominator of the function. Okay, the denominator of function is x plus 2, which will be equated to 0. So the value of our domain is, since x is equals to negative 2, this means that the domain of our function is all element of real number except x equals to negative 2. Because if the value of x is negative 2, the value of our function is undefined. Okay, next, the x-intercept. The x-intercept can be found by setting, or we let the value of y, or set the value of y to 0. So if y is 0, then copy the given x minus 2 over x plus 2 and then cross multiply. So we know that any whole number or even 0 has a denominator of 1. So by cross multiplication, this is x minus 2 times 1, that is x minus 2. This one, 0 times the denominator of x plus 2, this is 0. To simplify this one, we have x equals to 2, meaning this is our x-intercept. Okay, the y-intercept, just the same. We use the same function, then we set x equals to 0, since we are going to find the value of y. So if this x is 0, the remaining is negative 2 over 2, or simply y equals to negative 1. So this is our y intercept. For vertical asymptote, so you just look at the denominator and equate it with 0. X plus 2 equals to 0, then your x is equals to negative 2. So this is your vertical asymptote. Then for horizontal asymptote, the same. So you have to look at this one. So if they have the same degree between the numerator and denominator, then that is n is equals to m. If it is equal, then you have to take the coefficient of the numerator and denominator. So this is 1 over 1, since the numerator has only 1 degree and also the denominator is only having 1 degree. So the horizontal asymptote there is 1. Y is equals to 1. Okay. So these are part of the value that you are needed in graphing this function. So the last one is making a table of values for graphing. Okay, for this one, let us set aside this, then proceed to table of values. We will come back to these values when we graph this function. Okay, so again, we have here our function, then we will build our table of values. We know that our domain is all elements of real numbers except negative 2. So we will take note this portion. So we will try to evaluate numbers on the left side of this value from negative 2 going to the left and from negative 2 going to the right. What are the value of the function? Okay, so let us try these numbers and these numbers. Okay, what will be the function if the value of our x is negative 2, negative 6, negative 2.8, negative 2.45, negative 1.55, negative 1, 0, 2, and 6? So by substitution, we have f of x, let's say the value is 12. Okay, we'll only solve up to 3 examples, and the rest just the same procedure. You are going to solve that with this procedure. So f of x equals to, when x is negative 12, by substitution we have negative 12 minus 2 over negative 12 plus 2. So that is negative 14 over 10. So this is 1.4. So the value of our f of x at negative 12 is 1.4. 1.4. Okay, how about if it is negative 6? If the value of the function of x is negative 6, what is the value of the function? So this is negative, by substitution from the function, given function, then negative 2 or over negative 6 plus 2, that is negative 8 over negative 4, or this is simply equals to 2. So the value of our function at x equals to negative 6 is 2. Okay, that is how to find for the value of our function using this value of x's. So is 2, when value of x is 2.8, that is 6. That one, when the value of x is 1.55, then the value of the function is 8. When negative 1, negative 3, when 0, negative 1, when 2, the function is 0, then when the value of x is 6, then the value of the function is 0.5. So after that, that is the last, then we'll proceed to how to graph this function. Okay, so I have already written here the thing or the value of our vertical asymptote, horizontal asymptote, x-intercept and y-intercept. So what we're going to do now is to plot this one in our graph. So we have the vertical asymptote of -2. So this is the one. Then horizontal asymptote is 1, +1, that area. Then our x-intercept is 2, that point. Then our y-intercept is -1. So -1 here. Okay, so after that, now we have already the vertical asymptote, horizontal, x-intercept and y-intercept. Then we proceed to our table of values. When x is 12, 1.4, that one. Then when -6 and +2, that area, that this point. Then -2.8, then this point, then -2.45, that is this point. Then for -1.5, we don't include -2 because this is the part where our function is undefined. So we'll proceed to this point where x is -1.55 and the value of our function or our y is -8. So that is the point. Then next is -1 and 3, that point. Then 0 and -1 from the y-intercept. Then 2 our x-intercept. Then 6 and 0.5, that point. Then 12 and 0.71, that point. So if we're going to connect that one, this is now our graph of the given function f of x equals to x minus 2 over x plus 2. Okay, that is how to graph a given function. First, you have to look for the vertical asymptote, horizontal, x-intercept and y-intercept, then table of values taken from your function. Okay, next, example number 2. Okay, the given function is f of x. The given function is f of x equals to 4x plus 5 over x plus 1. Then the requirement is to find its domain, intercept, then sketch its graph, then determine its range. So the first one is the domain. Okay, the same, no? You have to look up for the denominator, then solve for the x value. Okay, for this we will equate this one with 0. So our x is equals to -1. So I mean to say that we do not include this -1 from our domain, so meaning that our domain for this function is equals to all elements of real number except x equals to -1. As I said, this value could make the function undefined. For x-intercept, we will use the function, no? We use the function. Then we will set y to 0 since we are going to find the value of x. So by substitution, we have y equals to 0, then copy the given plus 5 over x plus 1. Then as I said, cross multiplication. So this is 4x plus 5, then this one is 0. So this is equals to 4x plus 5 equals to 0, then we will transpose this one to the right hand side. So what is left is 4x equals to negative 5, then divide both sides by 4, then this is 4, so the remaining is x equals to negative 5 over 4, or 1.25. okay, so this is our x-intercept. For our y-intercept is the same, no? We have to set this one. For x-intercept we set y to 0, but for finding for the y-intercept we will set x to 0. So if x is 0 times 5, that is 0, plus 5, the result is 5. If x is 0 plus 1, the result is 1. So the value of our y is equals to 5. So that is your y-intercept for this function. For vertical asymptote, the same, you have to look at the denominator, no? Then equate it with 0. So your x is equals to negative 1. So your vertical asymptote now is negative 1. For horizontal asymptote, okay, you have to look at the degree of the numerator and denominator. As you can see, the degree of the numerator is 1 and the degree of our denominator is also 1. So what we're going to look for that is the coefficient. The coefficient of the numerator is 4 and the coefficient of our denominator is 1. So our y is equals to 4. So this is our horizontal asymptote. Okay, so those are we will set aside this one, then we'll proceed to the table of values. We will get this one as we start graphing the value of this function. Okay, we're going to build now our table of values, and we know that our domain is that includes all the elements of real numbers except negative 1. So we will take note that one. Okay, negative 1 is undefined. So we will determine the values to the left side and the right side. So for in this case, the first value that we have considered at the left side of our value, which could make the function undefined, is 6. So we try to solve what is the value. For two values only. Let us see f of x, where the value of x is negative 6, then this is negative 6. I don't know. By substitution, when the value of x is negative 6, then we have 4 times negative 6 plus 5 all over negative 6 plus 1. So by simplification, we have negative 24 plus 5 all over this one is negative 5. So that is 19 over negative 5. Okay, we will use a calculator to find for the value of our function. Okay, so that is 19 divided by 5. The answer is 3.8. So 3.8, the value of our function at x equals to negative 6, positive 3.8. So kana siya. Okay, the next one is f of x, where x is equals to negative 2. Then by substitution we have 4 times negative 2 plus 5 all over negative 2 plus 1. This is negative 8 plus 5 all over negative 1. So the result is negative 1 and positive 5, that is 3. Negative 3 divided by negative 1, that is positive 3. So your function at negative 2 is equals to 3. Okay, negative 3. So that is how to compute, no? So if you have time, you compute the rest of this one, of this value of x, to find the rest of the value of the function. So as I computed here, this negative 1.5, the equivalent value of the function is 2, that one is 10, and negative 0.75 is negative 8, negative 0.49 is negative 3, negative 1.22, that is 0. For 0 we have 5, then 2 is 4.33. So after that, all the necessary information or values are already ready for sketching the graph. Okay, so in graphing we have to plot first the vertical asymptote, which is equivalent to negative 1. So that one. Then our horizontal asymptote is 4, so somewhere here. Then our x-intercept is negative 1.25. Okay, here. Then our y-intercept is 5. Y-intercept is 5. So there. Okay, after that, we'll proceed to the table of values for the graph of our function. Okay, for this one, for negative 6 and 3.82, that point, then that one, this point, then that value, negative 1.5 and 2 here, then this one also here. Then we'll exclude that one because that is the part where our function is undefined, and that is what that is our vertical asymptote. So our graph will not cross or touch that barrier or wall. Okay, we proceed to this point, negative 0.75. Negative 0.75 and 8 is that point. Then this one, that point. Then this one, 1.5 and 4.5, this point, and this point 3 for this one. Okay, then 5 and 4.15, this point. Then this one, the last one, is 7 and 4.15, that point. If we want to connect that one, that is our graph of the function f of x equals to 4x plus 5 over x plus 1. Okay, the last example is f of x equals to x squared minus 1 over x squared minus 2x plus 3. Okay, So first we are going to find the domain of the function. Okay, so as you can see in the given function, we have first to reduce that one to the lowest form. Okay, so since this is factorable, then we have to factor it, no? The numerator and denominator. So the factor of our numerator is x plus 1 times x minus 1. For the denominator, that is x plus 1, then x minus 3. So as you can see that this is cancelable, so we will cancel this one and this one. So the remaining value of our function is f of x equals to x minus 1 over x minus 3. So this will be our reduced form to be used to the rest of the value of our x-intercept, y, vertical and horizontal asymptote. Now, to find for the domain for this, you have to look at that point or that denominator. So that is x equals to negative 3, equate it with 0, then your x is equals to positive 3. This means that your domain includes all elements of real number except 3. As I said, that number is the restriction, in which if you use that one, our function becomes undefined. For y-intercept, we have to use the same reduced form, no? Then set y to 0. Okay, as I said that f of x is just the same to y. So by substitution, this is equals to 0, then copy x minus 1 all over x minus 3. So cross multiply. So this is x minus 1 equals to 0. So your x is equals to 1, positive 1. So this is your x-intercept. Then for y-intercept, you have to use the same, no? But here we have to set x to 0. So your y is equals to, when x is 0, that is negative 1. When x is 0, so the answer is negative 3. So negative 3 divided by negative 3, then your y is equals to positive 1/3. Okay, that is the value of your y-intercept. For vertical asymptote, okay, you have to look at the denominator and equate it with 0. So your x, your vertical asymptote is positive 3. Okay, and for your horizontal asymptote, you have to look at this one. Okay, since both numerator and denominator are having the same degree, then your y is equals to 1 for numerator and denominator is also 1. So your y is equals to 1. So this is your horizontal asymptote. Okay, so after that we will move to the table of values before graphing all of these values. Okay, so take note that our domain includes all elements of real numbers except 3. Using the same function or this form function, which is x minus 1 over x minus 3. Okay, using this number, let's say 2.5. So if x equals to 2.5, then 2.5 minus 1 over 2.5 minus 3. So the answer is 1.5 over 0.5, negative 0.5. So the answer is, using our calculator, 1.5 divided by 0.5, the answer is 3. So this is negative 3. So negative 3. So this is the value when x is 2.5. Okay, let's try 2. When x is 2, by substitution, we have 2 minus 1 all over 2 minus 3. So the result is 1 over negative 1 or negative 1. So I mean to say that our function, when x is 2, the value of the function is negative 1. Okay, that is how to solve for the function using the given value of x's. So let us use negative 2. When x is negative 2, the value of the function is 6.62. When it is negative 5.75. When x is 3.5, then the function is 5. When this is 4, function is 3. When it is 5, the function is 2. When x is 6, the function is 1.66, and when it is 8, the function is 1.4. So we are now ready to graph this function. Okay, so we have already this vertical asymptote, horizontal asymptote, and x-intercept, y-intercept, and the table of values. So first we have to plot the vertical asymptote, which is 3. Okay, that one. The horizontal, that one. The x-intercept, which is 1, that point. Then our y-intercept, that point. So after that, our table of values. When x is negative 5, the value of y is 0.75. When 2, 6.62. When 2 is negative 1. When 2.5, negative 3. Then we will escape that one because that is not included in our domain. Okay, let's proceed to this point, 3.5. The value of the function is 5. Then when 4, the value of the function is 3. At 5, the value is 2. At 6, the value is 1.6. At 8, the value is 1.4. At 10, the value is 1.3. So to complete, we have to connect that one. Okay, that is the graph of our function f of x equals to x squared minus 1 over x squared minus 2x minus 3. Okay, I hope this video could help you in many ways, especially in graphing rational function. So for now, I will say thank you for viewing my video and hope that you will see my next video or the rest of my video, which can be found in my channel. Thank you and God bless.